Another one with the normal distribution. We're given that there's a mean of 500 scores on the SAT and a standard deviation of 100. And incidentally, these scores are designed to do this much. As they review the SAT, there is, if too many people start getting a question right, that it's made harder or removed, and not enough getting it right, then it's changed. So oftentimes in educational testing, the normal distribution and scores and such are done. So what's the probability that a randomly chosen test taker will score below 450? So the way this is, obviously below 500 is 50%, right? Because again, we draw this, here's our normal curve. What's going on is we've got a mean of 500, a standard deviation of 100, so that would take us down to 400 here with one standard deviation. And what we're looking for is 450. For this probability below 450. So we'll go ahead and maybe do a reverse of how we've done it before. We'll go ahead and use the normal CDF. So second distribution, we'll go to the normal. And our lower bound, this is where we could put in -1. They have this, where is it? I forgot where it's at. It's EE. There it is. It's right above the comma key. So we go second EE to the 99th power. It's kind of a way of doing infinity, negative infinity in this case. The upper limit we want is 450, sorry, 450. Then we have to put in our mean of 500, our standard deviation of 100. Now we could also turn these into z-scores as the 450 into a z-score if we wanted to, but we could do it this way, and we get a 30.85%. For decimal places, 0.385. Okay. Now, if you're going to do the drawing, what I suggest is taking this so that you don't have to redo your window each time. Let's find the z-score here, 450, minus the mean, 500, divided by the standard deviation. This will standardize the whole process. This gives us a -50 over 100, which is a -0.5. So we can do the same thing with the draw, and we'll be able to see exactly what's going on without having to resize the window. So we go to distribution, over to draw. We're going to shade the normal curve. In this case, we'll leave our lower at -1e to the 99th. That's going to infinity. The upper in this case is going to be -0.5, not the 450. We've got the z-score. And then we can leave the mean and standard deviation right where they're at. And I guess I have to figure out how to clear out this screen so we kind of don't see. I mean, we've got the right answers, right? But too much shading going on. I guess what we also could do, we could come back here. We change the color. Let's go to the right. Let's make it red, and it'll show up better. It's just this portion here back, right? Not up to the mean. It's about 450 back. So the thing I like about this is it does show us what probabilities we're getting below 450. If we want it above 450, it'd be the other side, and the answers would be appropriately listed that way. All right.